So I'm going to talk about developer tools. Unlike the previous two BOFs, this will be entirely user land. Above the kernel, um, uh, mostly above system level. So the tools that we are talking about are compilers and debuggers and IDE and analyzer, things like that. Uh, I'm Before I start, let me take a quick poll. Are you folks familiar with Studio tools in the past? Yes, maybe. Yeah, okay, good. So, if you're somewhat familiar with the tools have a long history. Actually, the tools used to be known under the name of Sun Studio before, um, but they were known by under different names. Unlike Solaris, which Sun was very careful about preserving its brand and so its name. The compilers and tools kind of went through a whole bunch of names, right? And some of them were kind of interesting. And we started with Sun compilers, went to something called SparkWorks, which was not just a Spark product, but also x86 and Motorola back then. Then we settled on Workshop for those of you who knew Sunsoft as a division of Sun. So there's various names there. We acquired a company called Forte and got that brand, and the developer tools along with Forte's tools kind of came under one umbrella. So there's a bunch of names there, and the last one of that lot is Oracle Solaris Studio. In the same grand tradition as SparkWorks here, even though Oracle Solaris Studio is Solaris Studio with a primary focus on Solaris, it also runs on Linux. So I'll talk a little bit about that too. I can quickly go through a couple of slides, but if you'd like to ask questions or if you want to interrupt and get some more information, we can do that too. So feel free to interrupt me anytime, ask your questions. There's no particular flow as such. Okay, I just have a couple of slides to take us along. So let me go full screen, I guess. So today, for Solaris developers, there are two choices. There's the GCC and GNU tools, fairly popular by themselves, and then the Oracle Solaris Studio set of compilers and tools. GCC is extremely popular with the open source community, and folks use it all the time to write, particularly if you're writing multi-platform code, right? Code that needs to run on not just on Solaris, but on other platforms as well. Right? It's community developed, community supported. The two popular compilers are GCC and G++. There's a bunch of other compilers too. GDB debugger and tools like binutils and autoconf, automake, which are again part of packages that open source software typically comes with. These were all previously on the Solaris companion CD. Sometimes known as SFW. Now they are in the repository, so you can download them as packages. So if you're here for the previous BOFs, you know that the installation scheme under Solaris has changed, so that there's no distinction between a regular install and a companion CD or packages, things like that. So you just have to ask for these products or tools by name, and you get them that way. Oracle Solaris Studio, optimizing set of C, C++, Fortran compilers. We'll talk a little bit about what their attributes are. There's a large integrated tool set. There's, of course, an IDE which does build, debug, tune, and a bunch of other things. But there are also point tools. There are tools that do debugging and profiling, in individual tools that you can fire up without having to go through an entire IDE. A heavier weight IDE cycle. They're optimized to leverage and showcase Solaris features. That's the primary target. Used to build the Oracle stack. We'll talk a little bit about that and a couple of other things here. But the last one is equally important. It's backed up by Oracle Premier support, so it's all rolled into the same support scheme that you might be familiar with from Oracle. We'll talk a little bit about that if you're not familiar with that scheme, how it's different from Suns to some extent, right? But just a quick snapshot of where the community is with the tools and what's provided in Solaris Express. So when you download Solaris, or when you install Solaris 11 Express, you can get these versions as well. They are mostly, almost entirely, very close to the latest community versions. The latest community versions very often don't make it into various distros for a while, right? And these are snapshots of when the tools were made available into Solaris 11 Express. Solaris 11 after the Express will get the later versions of it. So when there is a Solaris 11 GA, whatever the latest community versions are at that point will be incorporated as well. Both these as well as Studio are supplied into the Solaris organization, into the Solaris organization by the into the Solaris repository by our tools organization, right? So don't think of these as competition, right? It's not like we are not competing with GCC, we are not competing with GMake, or that's, the two are sort of partners as far as Oracle or as far as Sun are concerned, right? They are tools for developers, right? Whichever one you choose to use is fine by us. They have different attributes and different properties. So that's really what it's about. So a common question that I get when I talk about C++ compilers and Fortran, right, is, isn't all that stuff legacy? I mean, it's like you're still talking about C++, right? Who uses it these days? Well, two things. One is C was voted last year as the most popular development language. So it's back in after a couple of years of being second to Java. It's back to being the #1 language of choice for many developers. So yes, it's still very much there. And second, guess what? Most of infrastructure, large infrastructure projects still use C++. Okay? Here's a range of projects within Oracle that are built using Studio. Right? Not surprising for many of these things. We built Solaris. We have always built Solaris for 20+ years. Okay, but we also built the database. The Studio tools and compilers build the database, the Oracle database, as well as MySQL and other versions of database that are there. JVM hotspot is of course a C++ program, right? The NetBeans IDE has a bunch of C++ features. Siebel, PeopleSoft, JD Edwards, Hyperion, all of which are part of this of the stack, are all built with Oracle Solaris Studio. They all recommend Studio as the tool of choice for their own partners to ensure compatibility and interop, basically. So that's the big. When Oracle says that the new value prop is going from application to disk, the place where Studio plays in it is that it's used all over, right from top to bottom. A sample of Studio top customers. What you'll notice here is that almost all the top Spark or Sun systems customers are essentially Studio customers too. So Studio used in any serious enterprise that's out there. So and has been for about 20 years now. So there's a couple of things that we should talk about here for Studio. The primary purpose behind having our own set of compilers, our own set of debuggers, our own set of profiling tools is that they add value to Sun systems and to Oracle's own properties. Okay? Key among them is, so there are three things. They're optimized for Oracle Sun hardware. For years and years, this has been true that the compiler group has been working with the Spark design group, right? So even before the first Spark chip samples come out, the compiler group is pretty much involved with instruction set design and performance characteristics of those as well. We help the chip guys with the first testing that happens even in fab as they come out of the fab for the first time, even before, long before customers have seen them. So it's clear because of that we sort of know the secret sauce underneath that. What does it take to tune it? So from Sun, you would think that this would be obvious, right? Spark, Sun did Spark, so the compiler group would know this. But this is also true for Intel. We have also worked with Intel over the last like 5 years. When Intel designed the Nehalem chip, we were with Intel from day one of Nehalem chip. Well, I'm not sure if it was day one, but early enough, long before silicon was available to any vendor, right, including us. And so the characteristics of the Nehalem chip were incorporated into the compiler long before the chip itself was ready. So as you can see, we can take advantage of the latest of instruction sequences, of instruction selection, right from design stage on. The tools are optimized for Solaris as well. What that means is they have they leverage and they support Solaris features like dtrace, hardware counters, right? In order for us to know where we are spending time in applications. There are probes within Solaris that are exposed through library interfaces like libcpc. Hardware counters provide that. /proc, which is a way of probing a process, right? For doing things like debugging, for stopping, starting functions, things like that. Microtasking library, which is a parallel performance library, so to speak, when to implement things like automatic parallelism or OpenMP. We'll talk a little bit about that. Math library, which we deliver into Solaris as well. IPS, right? We are the compilers and the tools and GCC and GNU and everything else is delivered into repositories as part of the IPS system as well, right? Zones, threads, things like that, and we've used it all throughout. So as Solaris development goes in a certain path, Studio has always been involved with that as well. Okay? Additionally, what Solaris doesn't talk a whole lot about, but has always been true, is there's a binary compatibility guarantee within Solaris. So if you write applications in a previous version of Solaris, they will run in applications that are guaranteed to run in later versions of Solaris. So this is sometimes called binary compatibility, sometimes called upward compatibility. Solaris has done this, has had the guarantee from, I think from Solaris 2.4 onwards, which is probably about 15 years. No, 2.6? 2.6? Okay. It's either 2.4 or 2.6. Okay. Yeah, that's right. There's some structural changes in 2.5. You're right.
At 2.6, everything was pretty much locked down.
Okay. Yeah. So from 2.6, that's like what, about 15 years or so now?
About that, yeah.
Yeah, around that time. And to go hand in hand with that, so in order to guarantee that applications will run that way, there are two levels, right? There's one at the OS level where you need to worry about the linkers and the libraries and library API calls and making sure that the function calls still remain the same as they were before, not just by name, but how they receive arguments, things like that. Guaranteeing that that is true all the time. As well as making sure that when the compiler generates code or when code is generated in an application that then calls those functions, that also is called in the same order. This is actually a typically hard problem. You don't see this. This is why Linux and GCC have had such a hard time maintaining compatibility. It's hard enough in the compiler to maintain it from release to release, but to maintain it along with the OS is even harder. But this has been a key value proposition for Sun Systems and for Solaris for a long time, and it's one of the larger attributes of Solaris. Makes it easy to upgrade it, makes it easy to recertify applications in newer versions. Right? Additionally, compilers and tools have been optimized for developers. What this means is, although we understand that there are Unix in particular, not like Windows or Mac, where most developers have one predominant style of doing development. In Unix, people like much more freedom than in other operating systems. They like to put things together, which means not only would they not so there's no single way of characterizing all of them, which means that tools like the IDE, which is a great tool, you can do all your development actions from within one tool, have it fired up, it stays up for weeks and weeks and weeks, and you do all your work in there. Great workflow, but most Unix guys don't do it that way. most Unix guys are out there doing command line stuff, right? They want to type CC commands on the line, they want to type make commands on the line, they want to type DBX on the line, right? As you saw from dtrace and from the previous one, they're typing other stuff on the line, on the command line, right? They weren't firing up tools to do that. There's a lot of that, so the Studio tool set is a rich tool set of 100 plus binaries. So there's a collection of these things, all of which are point solutions. In addition to having the IDE, I mean there is the IDE that does that. And there's a certain marketplace for that. Additionally, there are 200 plus performance libraries, support libraries that are also in the package. Might be a bit of a surprise that Studio as a package is as big as that. There is, as I mentioned, a full-featured IDE that's based on NetBeans, for which the group has put in C++ support. And the idea behind it is to try and reduce development time. There are tools that are specifically geared towards problems that are really hard to solve. So there's a memory leaks detection tool. There's a memory error. So there's like bounds checking tool as part of Studio as well. So you can do all of these. These are significant developer problems. They take weeks sometimes to manually trace bugs that are related to those issues. In the same way, in parallel programming, one of the hardest problems is to do deadlock or race detection. So issues like those can take a long time, and they require significant expertise to go chase timing issues in applications. We have a thread analyzer that basically does this, provides this kind of help at runtime automatically. So you can significantly reduce your time to figure out bugs in applications that way. I should go back and go back to the first point on this. One of the primary reasons from a company point of view why we do compilers and hardware together is the first bullet there, right? If you are just happy with what's out there in the community, GCC is a perfectly good tool. It works just fine. Large number of people use it. It's on many systems. And to be fair, to be frank about it, I think people are more familiar with GCC than they are with Studio too, right? However, the performance in terms of getting squeezing the last ounce or the fastest sequence out of your hardware, it's just not there. Studio tools Studio compilers are about about 5x better than GCC on things like SpecFP for simulations, for quantum chemistry, there's a whole range of applications there which are very high, which are more focused on high performance computing, or they are computationally intensive applications, which in those applications the difference between performance between GCC and Studio is very significant. Okay. That's the kind of place where you see that the numbers are clearly much higher on Spark, right? They are not that as high on Intel, but even on Intel, the difference between Studio performance and GCC performance can be as high as 50-60%, which is not insignificant, right? These days, when you look at 4-core and 8-core chips that are coming out, right? 8-core perhaps is leading edge, but 4-core chips that are coming out, 50% less is like almost getting a dual-core chip instead of a quad-core chip, right? So I'm trivializing the problem to some extent, but you understand that there are many performance-sensitive applications for whom getting the last bit of performance is extremely crucial, and Studio is great at doing that sort of thing. So a quick glance at the product set itself, right? There's things that help with the build, tools that help with debugging, and tools that help with tuning and things. So there's the compilers, standards conforming, optimized for Sun systems. There's performance libraries that go with those, optimized math library. There's debugging solutions here, including memory debugging and coverage tools that are part of Studio as well. There's different ways you can do debugging. You can do command line using DBX as a command line tool. There's a point product called DBX tool, which is a standalone debugger. or there's a debugger UI that's included as part of the IDE. Okay, you can do all of those. There's deadlock detection and data race detection tools that we just talked about. There's a nice little tool that's kind of new in the latest version called Delight. Delight is a dtrace based tool, uses dtrace instruments underneath that to give a visual, quick visual representation of where your performance hotspots are in your application. Then you can click on a little hotspots button and it will take you to your source lines and show that in annotated fashion to show you how much time is spent in that function, what they call exclusive time, that is time spent in the function and time spent in the calls that the function makes. So the calls that are wrapped in the function. So there's easy ways of figuring out where your program hotspots are that way. Right? There's also a more detailed analyzer that gives you every single hardware counter that is in your system, right? That lets you analyze cache hits and things like that, right? All the way down to register information that you can get through hardware counters. Okay, so we talked about most of this. I just reading through the slides, you can probably see the same sort of things we talked about. Much better performance on Spark, right? Not as good on x86. Not the difference isn't as large on x86, but it's still significant, right? 46% better performance on integer, and 2x better performance on floating point. That's pretty good, and we're comparing with the latest version of GCC. So in each of these. So what this means technically for Sun or for Oracle Sun systems is these world records, right? Oracle can stand behind the new systems that are announced, like the T3 systems that we recently announced, or the Intel Nehalem systems that we recently announced, and clearly based on world records that we have generated, make claims on how good the systems are compared to the competition, right? When Oracle stands up and says, for example, that Exadata is so much better than someone else's equivalent appliance, right? Clearly, things like this play a part in that. Okay. So here's the other aspect of Solaris, the Solaris binary compatibility guarantee. The combination of Studio and Solaris has been careful about maintaining compatibility between various releases of Solaris as well as various releases of Studio itself, right? Among the vendors that are out there, Solaris and Sun Studio are probably the only vendor out there that guarantee this level of compatibility. And as I mentioned earlier, this is important when applications need to be moved over from previous versions to later versions. So as I indicated at the beginning, even though the name of the product is Oracle Solaris Studio, the same tools work on Linux as well. Yes, we support Oracle Linux, including the Unbreakable OEL version as well as the new version that Oracle recently announced at Open World, and it works on other versions of Linux as well. The same performance, it's the same set of tools that are on Solaris that are also on Linux. Clearly, there are some system differences, right? Mathlib works differently, libc works differently between Linux and Solaris. But as far as the compiler and application is concerned, the same sequences, the same performance, the same features, the same sources, and you get the same level of support on both Linux as well as Solaris. And we do this for a very simple reason. It's because in most shops that we've seen, most application developers that use Studio don't just use Solaris. Linux is in many of those shops as well. So this is a very practical thing for Oracle as well as for Studio to be doing.